So DefDoc is a project that I started, I don't know, 5 or 7 years ago, way back in the midst of time when I was in college. It's sort of languished since then, but I've been, tweaking it since then. But I think it's useful to be, I've seen that there is some interest in this kind of thing. So I think it's valuable to tell people that it exists. So one of the main inspirations, I've used Tech and LaTeX a lot, and it's got some great features. It has a great line-breaking algorithm that makes nice-looking paragraphs. It's got a sort of layerable macro system, which I'm sure everyone in this room appreciates, that kind of allows you to add more syntax, add more abstraction, more flexibility to your documents, and to have libraries that you can stack on top of each other, and so on. It's got a relatively simple data model. It's just basically nested sequences of horizontally laid out things and vertically laid out things. And there's lots of existing libraries. So you can find packages that do all kinds of random stuff. There are some negatives, though. The syntax is kind of weird. There's a lot of escaping, unescaping stuff that's kind of non-obvious until you actually read the source code to the implementation, and then you realize, oh, this is what the data model is like. And that's not the kind of thing you want to deal with on a day-to-day basis in your life. The simple data model is also a negative point. You lose a lot of information very quickly as these macros are translated all the way to the bottom of the stack. So you need to do a lot of, there's a lot of this quote like delaying and forcing type stuff that you can do, which is again a headache. All the data is stored in arrays whose size is fixed at compile time. So if your document is too big, if you're like writing a book, and you overflow the amount of space it has for such and such type of data structure, your only option is to split your document up into smaller documents that you process in pieces, or recompile Tech to have larger arrays. So yeah, that's not an optimal solution. So I figured Common Lisp, and particularly the Common Lisp object system, would be a great way to avoid some of these problems. There's a slot in these elements that I have in the application that it just has a list of the contents. That gives you a nice tree structure. And then it has separate slots indicating properties of the elements, so you have data and metadata that's associated with that, with each of the elements. And then I figured I can use mixins as well to sort of take these orthogonal things such as wrapping, flowing, floating, layout direction, whether it's a left to right or right to left kind of thing, or top to bottom, bottom to top, whatever. Those could be separated into different mixins, and then pulled in to create a concrete document element. For example, there is a class called a logical structure element, which is it's a sort of intermediate abstract class in DefDoc, and it lays out vertically down the page. It lays out its own elements vertically, and it itself fits into a vertical sequence. And it flows as well onto other pages. So it can be split. For example, a paragraph can be split across 2 different pages. And a paragraph is a logical structure element that itself wraps the elements that are inside of it onto multiple lines. And so I just simply subclass that and say it also does this. And then I decided, hey, for output, I can use classes too with inheritance. There's the output destination, sort of type hierarchy. One of the elements of it is the HTML output, which is also pretty printable. And as you'll see later on, you get nicely formatted and indented HTML out of it. There's a plain text output, which is a fixed width layout, and it has a slot in there that's inherited from the fixed width layout class. And by default, it's 72 M's, which are characters. And then there's PDF output, which is fixed layout, which inherits actually from both fixed width and fixed height layout, so that there the whole page has a fixed size. And all these classes affect decisions that are made via generic function dispatching, such as the two generic functions prepare and convert, which are part of the core engine. Prepare will take the input and break it up into the actual elements that should be laid out in the end. For HTML, it will keep the paragraph as a paragraph thing, and that'll eventually get output as a something surrounded by a p tag. For PDF, you would break it up into lines of text, lines of characters basically, or whatever other elements are in the paragraph. Then there's a convert generic function that takes those things that were broken up by prepare and outputs them to the concrete format that's expected by the file type that you've specified as the output. For HTML output, I used a macro there to abstract over the details of the kind of things that you'd be doing when you generate HTML tags out of DefDoc elements. It's kind of hard to read and follow, but basically it defines a method on the convert generic function. By default, you can optionally specify what HTML subclass you want. Otherwise, it just takes HTML class in general. It defines convert, which you can use to convert sub-elements. And also it defines convert to text, which suppresses basically all formatting. So for example, if you wanted to use it as an attribute for a tag, you can't, in HTML and SGML in general, you can't have, you can only have C data inside of an element attribute. So you need to suppress any kind of italic or whatever that's in there. So some actual uses. All I do to define how a paragraph is converted into HTML is say, for a paragraph, I make an HTML block that's a P and convert the contents. And with HTML block is yet another macro that I'm not going to get into because it does a lot of pretty printer details and it's kind of wacky. And then for an itemized list, it instead of just using convert, like here, it just said convert and the argument defaulting just pulled in the entire contents of the paragraph. Here, it goes through the contents and formats each of those elements as an LI tag. And then for links, here there's an HTML inline, which just controls the pretty printing details so that it looks like it flows in the paragraph. It shows that Here you can specify the href attribute of the a tag as part of, in this macro structure, and convert the contents. For discretionary hyphen, you can write out an HTML entity. And for discretionary hyphens in, for example, PDF, they would actually be handled at the prepare level, where it handles line breaking and decides whether, at that point it's up to the discretion at that point whether to output a hyphen or to leave the word as a as a single word on the same line. So here's an example of a project website document class that I've defined. It takes a title, which is required, and so on and so forth. Then there's a subtitle as well. Then there's sections in it for documentation, code, communication, dependencies, just different sections of a project, for a code project that you have, the kinds of things the kinds of major headings that you want on your page. Now you'll see that these are not, it may seem kind of funny that some define these as classes of section, but there is a kind of reason why I want to do that. Here, I've actually defined a way, a generic function called section before p, which is used as a comparator to sort, so that you can define the sections within your project website in any order, and then they're sorted according to some canonical order when you finally produce the document, and that way you can sort of abstract the detail of the sort of structure of the page versus from the definition of the semantic content of the page. Here also you can see I'm doing something a little tricky, where I wanted to have an itemized list of the dependencies and not require the person to make an actual itemized list. I'm not sure if I'm going to keep that. It's kind of wacky, so non-intuitive behavior here and there. So I might get rid of that. But it's an example of something kind of interesting that you can do, given the data model that DefDoc provides. So the DefDoc website is defined like this. It's a def package form that imports a bunch of Lisp packages, and now we go into that package. Looks kind of like a program that you're writing. You have a def abbreviation, and this is kind of like text \def. Here, this doc macro indicates that you're starting a snippet of DefDoc text, or of DefDoc objects, and it's an italic element, so this is actually class name, and this translates into basically make instance quote italic with no options for the attributes of the class itself, and then contents being def. And then it's followed by a small caps element, doc. I've also done def abbreviation for LaTeX, and I didn't bother doing all the stuff. But I've abstracted that away so that when I do decide to take the effort and actually do the subscripting, superscripting, it applies through the whole document, and I don't have to worry about, oh, now I got to go search and replace, and hopefully I don't get any false matches and all that. Also, I've defined some functions, just plain old Lisp functions, to concatenate strings, to generate links to the source repository. You'll see how that's used, and to generate links to the different mailing list home pages. And that way I don't need to worry about in the document, this is the structure of the commonlisp.net, website. I can, sort of encapsulate that in this section of code, in this section of the document, and not worry about it later on. So I'm defining a document called index, which is the index page of the website. It's a project website. Given parameters, name is DefDoc, and this gets looked up in that abbreviations thing, and so it gets, but inside the conversion routines, when it's output as the title, it suppresses the HTML formatting, so that because the title of an HTML document is not allowed to contain any HTML tags. And there's a short description there as well, which is decided to not have that, fill up the page, the presentation here. And you can specify the author and so on. So that gets translated basically into a make instance, and also gets put into a hash table so you can refer to the document called index in other code. And the name, short description, author, those become inidargs in the make instance, and then the contents, which you're going to see in a second, are also another inidarg that's passed in. So this is within the DefDoc form. There's also it has as the body of it. It starts off with a documentation, and that's parsed as recursively as make instance of documentation, with contents being this, which gets recursively processed as make instance paragraph. So it's kind of Lispy in the way that it's recursively processed according to certain evaluation rules. And this is actually not the final syntax that I want to have. This is just something that I hacked up. So the Lisp, I just use the Lisp reader. And so I have these quotation marks everywhere, and it's basically inverted from what you really want to do in when you're writing a document. But it's workable. And here you can see I'm putting links, to an overview page that's in various formats. Here is the code section, and I have that gen source link thingy that I'm using here that generates the URL to the link that will take you to the code, and then it'll say, and then it also says that the various sections of the code, you can just jump straight to them. And blah, 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 blah. And you can see that it looks kind of ugly with all the quotation marks scattered everywhere. It's kind of hard to follow. And yeah, that's a future enhancement that I plan on, is to make a nice front end. And I also mentioned that the website is actually a DefDoc document, and I can have a link to the CVS repository, so they can see this document that I'm showing you now. Dependencies has a link, the whole URL there. Here's a mailing list kind of thing. Uses that function that was defined before, the same way that the source links were done. And that's pretty much it. And in the end, you get, let's wait for Firefox to load up. And that's what it is. This is the result. You can see the source. The source is relatively nicely formatted. It's not just like one big mess of you know, run on stuff with new lines thrown in there randomly whenever someone decided, hey, let me just put an enter here, like /n in this string.
And that's the wacky path, right? That's the wacky path that you mentioned before.
The what?
With HTML formatting or some macro that you said is wacky.
Yeah, it does a lot of pretty printing. It actually just uses the Lisp pretty printer to output this. And it's a really well designed interface, except that the algorithm is not text algorithm, so you get ugliness where things run on forever, or things indent very deeply without backtracking and saying, wait, we should, you know, break the line before the thing that requires an indent. And that's pretty much because it doesn't use text line breaking algorithm. So that's also another thing that I have in mind, is to use DefDoc to parse Lisp source code and format it nicely in a variable with kind of you know, variable with window or onto, you know, a page, and then you can change the font size and it'll just rewrap and look nice. So yeah, any questions?
Have you looked at the BRL reader for inspiration on your front end?
No, I have not looked at BRL reader. Okay.
Could you use the same source code you have to generate PDF output for that?
Yeah.
Can you repeat the question, please?
He was asking if you could use the same code to generate PDF output, and yes, you can. Technically, you could, but there's no PDF backend. That's a Summer of Code project, in case anybody wants to apply. Yeah.
So that was my next question. Are you rendering PDF or are you doing it full backend?
Well, you could do either way.
The question is, are you rendering?
I'm not doing any of that. Right now, the only thing that actually works is plain text works somewhat, and HTML works pretty well.